Happy morning to all. We have our same resource person, Dr. Ajit Kumar, postdoctoral researcher in Sonsal University, South Korea. Now he's going to present on the topic hands-on with Scikit Learn 2. So I hope we'll have a nice interactive session. Please participants all join. So welcome, sir. It's not audible, sir.
We are starting or we are waiting for more participants to join?
Sir, shall we wait for 5 more minutes, sir?
Yeah, it's okay. Yes, okay, because very few people have joined it. So we will wait for some more time, 5 minutes, and then we will start.
Okay,
Audio is clear now?
Yes. It's clear,
Okay.
sir.
Okay, thank you. Yeah, we'll wait.
Good morning, Dr. Ajit Kumar.
Good morning, ma'am.
How are you?
Yeah, I'm very fine, ma'am.
We are waiting the participants to join.
Yes, ma'am.
So in the meantime, I would like to invite the participants, if they want, they can introduce themselves so that you can share, or you can, that is, you can give about you. Any
Yes.
participant willingly, you can switch on the video, and because we are waiting for the participants, maybe 5 minutes it will take. In the meantime, I would like you people to introduce yourself. Before that, I request Habiba, that is Madam Habiba, to introduce herself. Yeah, you introduce yourself. You're the person who is coordinating the whole show. So you introduce yourself.
Hello all, I'm Habiba. I'm the research scholar under the supervisor Dr. G. Aguila. She's professor in the Department of CSE and register and start in NITPY. I'm very glad to work under her.
What is your research area?
Sir, I'm planning to do in cyber security and with machine learning, sir.
Okay.
Sir, in cyber security, can we go for cyber bully, sir?
Yeah, that will that will become NLP problem, cyberbully, or if you want to take like cyberbully is two type. They either send you the messages on social platform or send graphics. So if you are trying to protect or filter those things, either you are doing NLP or you are doing image processing. So you have to decide on that. When you say cybersecurity, then you are working in some other domains. If cyberbully is like one of the application of text mining or image processing. So you have to decide on that thing. Cybersecurity is like technical part where we do like intrusion detection, different kind of attack. Like I worked on malware detection. So today I will share that malware detection, how we work. So maybe we'll get some idea. Or you can work on now IoT security where we do network analysis, network traffic analysis. So that is a totally different domain than this. So cyberbully will mostly come under NLP or image processing. Yeah.
Any other participant you would like to introduce and have any things to share?
Okay, thank you, sir.
Yeah, thank you.
Sir, but it is a security threat, so which is
no, that
social networking.
security threats, when we say, are you talking about technical security threats or you are talking about social security threats? That's come under, yeah, that's under social security threats. That's not on like we are not attacking any device or we are not using some information to attack a network or computer. When we say cyber security, information security, cyberbully will be like different, that will not fit into this domain. That's like attack on a human, not on a device or network or something. There are some work, but you can work on that's not that is a good topic actually. That's a social impact. That is the bright side of that work, but it will not come in cybersecurity. But that is very important topic to work today. Like iOS Apple have also released one for pornography, child pornography. They are saying now they will scan mobile devices for such kind of image. So this domain is going. It's good. It will be social and computer. And if you are applying machine learning, you can do on that. Yeah.
So participants, can you please introduce? We'll wait for 1 or 2 minutes, then we'll start the session. Yeah. Anyone is willing?
Maybe Dr. Ajit, can you give your experience in Sunsil University?
Yeah, so thank you. So I have joined my postdoctoral position last year. So from then I am working on a different domain on security, like a smart grid security, where we are looking on how we can secure power grid, like modern power grid have ICT also involved. So from then we have been working on that. So last two paper we have published on false data injection attack, like when in a smart grid there are lots of data communication. So attacker want to inject some malicious content into those data to manipulate the control of a smart grid. So detecting that is very important. So that's we did with machine learning. And now we are trying to how we can correct those values. So this injection can come from like machine fault also. So now we are looking into how we can use machine learning to correct those value. If value is wrong, so what will be the probability distribution? We can just try to correct those values. So that is like technical part. And yeah, life in Korea have been very nice. It's very organized and we have lots of resources for research. So I have been a very good research contribution here. So yeah, life is good.
Okay, you're associated with the Department of like Computer Science and Engineering, or how is the hierarchy in Sumsil University?
Actually,
The departments are divisions or sections? How
yes,
it is there?
it is like my professor is in engineering and electrical department joint role, but at being a postdoctoral, I am only associated with my professor in the project, and only the research organization of like research wing of university only take care of our communication. So we don't have to interact or we don't have to follow any hierarchy. So only I report to my professor, and if any documentation is required, there is a research team that takes care of everything. So it's like flat kind of hierarchy. uh, Only me and supervisor we work together, so we don't have to. This is our lab where I'm sitting. It's shared with two professors. So my professor, a scholars researcher, and one more professor researcher. So we all share this lab with our own computation and everything. We have our own project funding. So we do all these things with that. So mostly it's work here as a project funding. Professors should have projects and then they hire. So all are like hired. They use term hired. It's not like fellowship. We all are like on payroll basis. All the master student or PhD student, even postdoc, we all are on payroll. Even masters, they get salary to work. It is hourly also. You have to pay the master student.
Thank you for the information.
Yeah, thank you. So I think it's now 9:30. So I think we should
Yeah,
start.
we will
Yeah.
start.
Yeah.
Okay.
Yeah. So can Habiba, can you enable my sharing?
Sir, I made you as
Yeah.
presenter, sir. You can share.
It is not enabled. Can you check again? Oh, so maybe I think I have been logging with mobile also. So you have chosen some other that one. Can you disable that another hosting and enable this one?
Yes, sir, I'll do, sir.
Yeah, because that's to see the slides is coming or not. I have just logged in with some other machine also. Hello, is there any issue? I am not able to share.
Yes, sir, a minute, sir.
That's not my account. Habiba, I will just close that account. That's from mobile phone.
Okay, sir.
Another account, this account that I have mentioned, later I will close it. I just put it for seeing that a screen is okay or something. Yeah, thank you. Now I can, yeah. Okay, so good morning, everyone, and welcome back. So yesterday we started with the introduction of machine learning, and then I discuss about different kind of data like text, audio, video, how we'll process and load those data for machine learning model, like how we can train. So if you remember from yesterday diagram, we have input, we have algorithm, and then we try to train and say we get the model. So today I have focused more on training, so how we can train and we can use evaluate our model, and then I will give little more time on deployment also. So many of time you will have less information about how to deploy this model deployment, so I will include that example and we'll focus on that. So let's get started. So for today I have just a brief introduction of machine learning algorithm, where I will just say what are the different algorithm and how they work together, and then what are the training, testing and tuning method, how we test, train, and what is the tuning. And then there are different deployment method and modules, so I will be discussing on that. And then I will have a use case where I will show how to do from data collection to deployment. So this was my work on malware detection, so how you can build a web application for malware detection. And then I will take question and discussion. So from yesterday, we have machine learning algorithm, we have supervised learning, unsupervised learning, and reinforcement learning. So we have discussed this yesterday. So supervised learning, when we say, it's very clear that we need input data and we need the level. So level, if it is a classification problem, then we will have classes of those, say apple versus orange. We can have multi-class problem where we can have more than two classes or more than many classes we can have. Say suppose we are classifying that another example where we were taking 6 type of natural scene, forest and buildings and all those things. So those are like supervised tasks. So in that supervised traditional machine learning, we have decision tree, we have name base, we have KNN, and many more. So if we go to this supervised learning, I will just open that page later. So you can see that there are lots of algorithms and their variant. Say suppose decision tree. So many people are working on decision tree. Over time, they are trying to improve many part of this algorithm. Someone want to improve the computational time. They want to have less computational time. Someone try to improve the speed. It should train fast. Someone trying to optimize the memory usage. So all this optimization people are working, and all result into the variant of same algorithm. So decision tree core algorithm is there, and then there are different variant of the decision tree. Likewise, naive Bayes, there are lots of variant. So we will go a brief introduction on that, and then we will move forward. So this is one just to think about how this algorithm are being developed. So machine learning algorithm, if we talk about decision tree itself, there are different variant of either their calculation function like information gain, entropy, all this is there, but how they are calculating or how they are optimizing this. So based upon that, there are different variants. So this is where I also want to give importance that in machine learning research, we have two areas to work. Either we work on algorithm level, where we try to improve the algorithm itself, independent from any data type or any special problem, like any domain related problems. We are not fixed with domain. Researcher work to improve this algorithm. So they have like theoretical background in this computer science and then work algorithm only. So if they optimize decision tree for one problem, it should work on another problem also. So they work on that. So that is one research. Or another research where we look for optimize for domain, like we are trying to classify a cancer a scan report, we want to make it very useful. So we just use this algorithm. So where it's become application of this algorithm. So that's what it like practical how we can use this algorithm. So that is different domain. There the importance is given to the domain knowledge. We have more domain knowledge, then you can have more intuitive feature to have more discrimination value of those features. So that is also one kind of research that's like application of machine learning. So we have this kind of algorithm, Bayesian, decision tree. All these are like, if you see this arrow, first arrow, this give a different family of problems. So like decision tree works on information gain and or entropy calculation. They calculate information, that is like tree base. Then if you come to the Bayesian, then they use conditional probability, and there are like different variant of that also. If you come down, instance based or lazy learner like K-never, and all these are like lazy learners. So that is also. Then we have in unsupervised, we have clustering. There are different variants. This side, if you come, we have regression. So regression is one concept where we try to fit a line between our data. We try to minimize the error, on there are different method to calculate error also. That is one just concept from statistics. Now based upon that concept, we have different kind of machine learning, linear regression, we have a stepwise regression. So these all are logistic regression. So one used for classification, another we use for prediction. So this kind of things are there. So these are the variant of regression. Then if you come to neural network, we have basic neural network like early days neural network. Then recently we have now deep neural network. So deep learning, we have different algorithms. So then we have one very special class of machine learning problem we call ensemble learning, where what we try to do, we try to use this basic machine learning with some different combination or arrangement. So we have random forest, that is based upon decision tree. We have GBM, we have AdaBoost. So all these are like used either of this basic algorithm, and they arrange in some special function to optimize the result, optimize the performance. So this is one basic concept. So now if you want to have domain, any domain you have chosen to work on that area, then you can fit, we can see, you can just go through this and see which algorithm is more suitable to your problem, and based upon that you have to go into the detail of that algorithm, what kind of feature they are expecting, how they are working, what is their internal calculations. So suppose if some algorithm works on number very well, they need ordinal value or numeric value, then if your feature having a string, then you have to think how we have to convert this, or what we have to do. If you have some data set on image, then you have to think you are going for this traditional machine learning, or you are going to use neural network or deep learning. So this is very specific to your problem, and then you have to learn on that. So I will mostly try to have practical how we can use. So in scikit-learn, we have all this algorithm implemented. We have to know the basic, which algorithm we want to use, and we can train our model. So then we'll come back here. So once we have that training set, better I will just try to show you some scikit-learn thing that is very important. So if you open the basic site of scikit-learn, if you see, they have also classified like classification problem. So in this, all the classifier will be there, all the algorithm, and there are many. Then we have regression, where all the regression related algorithms are there. Then we have clustering, where we do all this clustering related algorithm. Then we have dimensionality reduction, where we try to reduce the dimension. Then we have some model selection and pre-processing. We'll come back on this because I have added some demo. So this is the main what we do. We either classify, or we use regression, we cluster, or we reduce the feature. Then these are like pre-processing, and then we do the some model selection or tuning. So if you go to the classification, these are the variant from previous diagram. If you can recall, we have linear model, lots of algorithm. One is different from another in just slight contribution made by some author. And what is good about why I'm trying to show you this, what is good about this documentation, they also mention the reference paper from which paper these all methods have been implemented. So if you want to do research on this algorithm side, then you can take algorithm implementation from here, and this is open source, so you can get the all Python code itself, like how they have implemented class and what are the object or function method they have created. All that you can get. So that is implementation. And then other side you can get the research paper also, from which concept they have implemented this method. So if you are trying to have some algorithm or new method to optimize, if you have a mathematical or a statistical background and you want to work more upon the algorithm side, then scikit-learn is very good place where you can pick up some algorithm, see their mathematical foundation, and then you can apply your knowledge and try to improve or change or propose new algorithm. So if you click any algorithm, they will take you to the paper also. So lots of classifications are there. One cannot master all, so you have to choose which algorithm you are working on, what is your problem, and which algorithm is more suitable to your problem. So I will just see anything related to decision tree. So it is decision tree. So this example is very basic example, and anyone can try this and learn. So my suggestion is I will go with data set training, but my suggestion is if you want to learn any algorithm, try with this basic example, because here you don't have to do anything very big. They take a small example, and then with the version, it is whatever version is there, if you have installed, it will run properly. So you can learn basic from here, then you can migrate to training data set. So if you come down, they will explain all those things, and then at the last they will have example, bigger example with data set, like all this data set, and then reference also. So this is what I was talking about. They give you reference also with some unique paper also, like fast multi-class image annotation. And so this is the international conference published in 2009. So now if you are working on this domain, especially multi-class image annotation problem, then this paper will become very useful, and you have algorithm also, example also. So now you are very prepared for your next step. You have paper, you have code implementation of existing work, and then you can move forward. So that is the purpose of showing this. So like for everything, they have example, they have all this mathematical formulation also. So if you want to learn, you can use some book or material, but scikit-learn documentation offer a very good organization of all those things. So all these references where you can have this core references, classification and regression. This is very foundation paper on this classification. So all these paper are like foundational paper on machine learning, on decision tree and regression. So that is the purpose of showing this documentation. So likewise for everything we have this one. So going back to our presentation. So now once yesterday we have load our data, all the images or all the text we have loaded into Panda data frame. So now when we go for training, we can train all data, that's okay. But how we'll know how our algorithm is performing? So in normal software development, we have something we call testing, where what we do, you write the test cases. So suppose if you are writing a program for odd even number detection, then you know that when I give input 2 to our program, it should say even, or if you are dividing and calculating the zero remainder, then you can say if I give 2, then function should return 0. If it is even, if it is 3, then it should return 1. So you know that for this set of input, this should be the output, and you put into the use cases, then you run your program under that use cases. If your program pass all the use cases, then you say your program is tested. Then there are different kind of testing like integration testing, a smoke testing, all those testing having different purpose to verify the software. So that is how we do the development of software. What about machine learning model? We have trained a model. Now how I will know it will work right or not? We have just passed the data, we have passed the level, we have passed the algorithm, say suppose classification or regression, and then we have done that. So to know how our algorithm is performing or how it will perform, we do something called testing in our machine learning also. So training and testing data set. So what is training and data set? It is little different from our software, traditional software testing. Here what we do, we just divide our data, whatever data we have. If we have 1,000 sample of any problem, we can take a rough estimate is 70% for training and 30% is for testing. So what we do, we take 1,000 sample, we just split it. Either you can use Panda or Scikit Learn also have some library trainer split where just you pass the percent and they will split. So what you do, you split 70% for training and 30% for testing. Now this split should be done for level also and data set also. So now you will end up having, if you are doing by yourself, I will show you how to do or what I mean. When you will try to do manually, then you will end up having 4 array or say suppose 4 data frame. So one will be input value for training and equal level, equivalent like respective level, that will be 1, 2 array. For testing, you will have input and then you will have features. So that's how you will pass to the algorithm. So in scikit-learn, all the algorithm, all the classifier takes mainly 2 input, and that is, if it is supervised, you have to pass X or training data, and then you have to pass Y, that is your testing levels, sorry, training levels. Either you can, that is the convention people use, or scikit-learn at least use X for training data and Y for training level. Similarly, when you split it, then it's become train X, train Y, test X, and test Y. So these 4 variable you just remember: train X, train Y, training data, training level, test X, testing data, and test Y, testing level. So these 4 you can do it manually, or scikit-learn will have this. This is one way. So I will, then we have cross validation. So this is initial way of testing your algorithm, but it is not very robust. That have some problem of overfitting or model will not generalize. So then we have another method called cross validation that I will see next. So that is only if you are doing training and testing. Then third thing is, I have put validation data set. So training, testing, and validation, or training, validation, and testing. Either way people use it. So what is this? Now, instead of having 2 split, people try to have 3 split. So what is the purpose of 3 split? There are results which suggest when we try to optimize our model with testing or validation data set, we try to tune our parameters. So when we tune our parameters, there are chances or there are proof that some information about test data set is leaked to the model, and model learn from that information also. So if it is like in exam, you know the question in advance, so you will perform very well in examination, but the question is, you really learn those concept or not, you know that concept or not. You go to the field where you have to apply your knowledge, but you are not able to do, because when you were testing, when your performance were being tested, somehow data from test is leaked to you, and then you have performed well on that experiment, but you are not able to do the task. So similar thing is with model. When we are trying to train our model with test data and doing optimization, we do lots of parameter tuning. Somehow in some cases, not for always, not always true, but there are some cases where the information from test data leak to the training part. So now model learn from the test data also some information, and that result into overfitting. To avoid this, what people suggest, that if such kind of model you are using or such kind of process you are doing, then you split your data into 3 parts, and then you try to have training test for your training the model, building the model. Once you are done with all the tuning and everything, then you test finally your model on validation data. That is not part of optimization also. People use interchangeably the name validation test or testing data set. If you are just validating with model, that is validation, or you finally you are putting your data for testing, you are doing the testing. So that's how you, if you see the Kaggle setup also, that Kaggle machine learning, they host many competition. So they will give you train and test data that you can learn and build your model, and then they will hold some data with themselves as a validation data set that is private to the organizer, hosting organization. Once you have done all this model training, you are getting 90% accuracy or 95% accuracy. When you submit to the competitor or that hosting Kaggle, then you see that your performance came to 70 or 80 or something. So these are the reasons, some reason that whatever, when you are tuning that model, you have used some information from the test data. So when we put a new fresh value that is not known to the model try to not exist the same performance that it was showing with the test data. So that is validation data. That is also upon your experimental design, how you are designing your experiment. Then we have performance evaluation. How already we are saying performance of the model. So how we do the performance evaluation? So we have different kind of metrics, accuracy and confusion. All this I will again explain in further slide. So this is like accuracy, confusion matrix. Then we calculate precision, recall, F1 score, and ROC and AUC. So I will explain. These are very important. So I will explain one by one. Then we do some hyperparameter tuning. So just every algorithm have different argument or attributes that we can just try to say. If you take decision tree, we have two type of entropy, like we can calculate using information gain, using like Gini matrix or entropy based. So we can change Gini to entropy and we can see which one is performing best. Then how many node we want in that root node will be one, leaf node, how many node we are trying to have. So based upon the number of node, accuracy also or performance also change. So these all value, if you are just trying to check everything and see which one is working fine, that is called hyperparameter tuning. So trying to, here we are just trying to change value of algorithmic parameter and we see which one is working fine. That is, and then for that purpose in scikit-learn we call something, I think some message. So in scikit-learn we say grid search. So grid search give you opportunity or function that you can just pass your algorithm, pass your data and pass this all parameter value range, and they will make all the set and perform all the trying testing and tell you at the end which setup, because there can be more than one parameter that you want to optimize. So finally they will say which setup is working fine for this problem. So that is called grid search. That also we'll see when I will go for demo. So first, cross validation. So cross validation is very important. That's I have put it first. So cross validation, as I said, when you do the split, train and test a split 70 to 30 or 80 to 20, what is you are doing? You are reducing the total number of training sample. If it was thousands, then you have just make it 800, 200 sample you have lost. So there are cases where you have very less number of sample and you cannot afford to reduce the training data set. So what is the solution? You want to make it more robust also and you don't have enough data. So that is one reason people use cross validation. And another reason is we try to have more robust. So cross validation result into more robust performance model. So how we do? So one is the very basic model is k-fold cross validation. So k is the number how many times you just want to do this training. So if you have k, then we try to divide data set into k smaller sets. It is different division than previous. We are just, you can say just we are marking. So suppose if you have 100 data sample, then we try to have 5. If you are doing 5 cross validation, then we just make a 200 set of our data set. So we have now 5 data set. So what we do, out of that 5, we try to, if you see here, we try to use one fold for testing and we train our model on 4 other folds. 4 other splits. So, and this is the fault. So we have divided our data set into 5 split. We use 1 split for testing and rest of the 4 split for training. And then we come to the next, it is 5-fold, 5 cross validation. You can do 10, you can do 20, and the same thing will apply. So we go to fold 2. Now we change the test data set. If you have done testing with fold 1, split 1, then we just move to a split 2 for testing. Likewise, for every fold, we change the data set, testing data set. So what happens over time? We are just every time we are training with 4 a split and we are testing with 1 split. But the testing a split is always different, and that's why we have also some variation in our training also, because which was testing in last fold, now that become part of training in this fold. So this give a very robust model. We can do 10 time or 20 time also, but mostly people use 5 to 10 split. So that is cross validation. Or this was the previous example where we have all data, 1000 sample. We just split into training data on 10 data. We just train on training data and test with this one. So this was earlier model. So down one, this one is your cross validation. So this is very robust. So most of time we will be using cross validation. I will show you that example of this also. So this is all, if you know this concept, all these are pre-built into our scikit-learn model. So yeah. Now, so I think, so that is cross validation. So just I am giving brief, and then I will move to the Handson where all this term will come. If there is some doubt, again I will repeat there. So performance simulation is very important, and we have mainly accuracy. So accuracy is just number of correct prediction by total prediction. So suppose if you are predicting 100 test data, so if there are like 90 they have correctly predicted, say suppose Apple, and there were 100 total prediction, so 90 is correctly predicted, so it will become 90% or 0.90, so that is 90%. So accuracy will become 90%. This is one of the, you can say, just normal way to saying how our model is performing, but that is not robust. There are many chances where we want to know how many they have corrected wrongly and which X and Y they have, like apple or orange. If you say how many orange have been wrongly classified as apple or likewise. So for that reason, we have another prediction. It is taken from already that we have in a statistical, this one confusion matrix. So what we do in confusion matrix, if you have binary class, so we something called true class. True class is like true label. You can say apple orange, and this is the predicted class. We put plot into how many classes we have based upon that matrix we make, and into m matrix we make of the information. So mostly we have positive and negative. It is two class. So this is true class, and then this is predicted class. So now we have term called true positive. So true positive is the positive sample. You can have any class, and that is classified as the same class. If it is apple, classified as the apple, that is true positive. So this area, its level was positive, and it is also classified as a positive. So suppose apple means this was apple and predicted also as a apple, so that is true positive. Then we have false positive. False positive is just it was orange, but it is correct detected as a apple. So that is predicted class is positive apple, but that is false. So that is false positive. Negative sample classified as a positive. So suppose orange classified as a apple, that is called your false positive. Then false negative. This is false negative. Your positive sample is classified as a negative sample. So your this one, and then this corner one, it is true negative. So this is similar to true positive. Negative sample classified as negative. So total orange classified as orange. So when you see this coordinate is, we want to have more value on this coordinate, and we want to have minimum value on these two coordinate FP and FN we try to reduce, and TP and TN we want to increase. So this we have, if we have more value and this, we have a better model performing. So if it is 0, FP and FN is 0, it means very ideal case, 100% true, but that is never the case. So that is confusion matrix. So this value give you some information, but that is not all. You cannot have very decision making on based on that. So this become the foundation of some more robust performance metrics that is called precision, recall, and F1 score. So from previous, precision is just ratio between the total number of true positive and total number of positive. So how many positive samples were there and how many were truly classified as a positive, that is called precision. So we divide total positive TP, total TP by total positive, so TP plus FP. So we just add how many positive have been classified as a this one falsely as a negative. So we add that and then take that value to divide total positive. So that is give you precision. Similarly, for recall, sometimes we also call it sensitivity or TPR. It is true positive by true total number of positive instances. So we just divide again true positive by all this one, so that will give you recall. Based upon these two, precision and recall, we have another matrix that called F1 score. So this is nothing but harmonic mean of precision and recall. So the purpose of this is that which having the lower value, we can take normal mean also, but normal mean treat all the value equally. If you are dividing age, taking mean of age 2024, then it will have like, they will not have any thing on for 20. They will consider both value together and they just give you the mean. Whereas harmony mean compensate to the lower value. So that is like this one. So we just take this precision and recall and then we just divide. So this is the formula for harmonic mean. This is harmonic mean of precision and recall. We can represent like for calculation purpose like this also, or there are other representation also. All these three is very good. Then we have another one also that is called receiver operating characteristic ROC curve. So we try to plot a line chart that is true positive rate of is false positive rate. So TPR already is I told recall. We try to plot recall versus FPR, false positive rate, and that's give you a ROC curve. So I have also given more time in demo for this purpose, how we can plot ROC, how we can plot ROC for multiple model. If you have one data set and we try to see how different classifier is performing, then we can train more classifier and we can plot ROC of each on one plot or separate plot also. But separate plot is difficult to compare, so I have tried to put it together. So all this demo I have included there also. Again, we will discuss this one. Then last one is AUC. So AUC is area under the curve. So when we plot ROC, the top, I will show you in diagram, the top one, if we are more on the top part, that is good classifier, and whatever area comes under that, that is considered as a AUC. Maximum AUC is good, and likewise ROC. So we from ROC we calculate AUC. So all are like interlinked. So to calculate ROC you need a recall. For recall you need confusion matrix. So either you can do directly in Scikit-learn, there are function methods that give you direct access of this, or there are like individually also you can calculate one by one. So we'll see how we can do it in Scikit-learn. So these are the link. Even Scikit-learn we have model evaluation where they have discussed all this along with more more performance metrics. So I have just included I think 7. If we go back to our Scikit-learn, you will be surprised to see how many performance model they have. So if you start seeing, this is metrics and scoring, quantifying the quality of prediction. So this is 3.3. If you start seeing how many performance metrics they have. So again, this is all the variant from research. So people who are not happy with accuracy, they propose some variant of that. So there are like accuracy, variance accuracy, top 10 accuracy. So these all are the precision. And sometimes Scikit-learn also try to give you some more results. So that's why they have some parameters. So these all are matrices. If you see ROC, there are different kind of ROC, weighted ROC, F1 major, F1 micro. So all this, some of this apply to some particular classifier also. So we cannot have all these matrices for all classification or all the clustering problem. No, we cannot. These all are limited to some classifier also or some algorithm also. So we should know which one is suitable for which cases. So that's why if you want to do, you can see for classification, we have all these matrices. For clustering, we have this one. So if you know the level, suppose in clustering, there are also cases where we know the level and we just want to see how algorithm is performing. There we do the homogeneity score. So likewise, we have more of this test. If you are doing regression, we have this all for variation R2 and mean square error, median absolute error. So this all coming from your statistics, mean Poisson value, so Poisson distribution, mean gamma. So like all these are different kind of matrices, especially suitable for regression. So this is classified also by Scikit-learn. Among this classification also, someone works with some algorithm, other work with other algorithm. So you have to go one by one and you can see all these are hyperlink. So if you click any of this, you will end up a Scikit-learn documentation page, which will give example, explanation, and some code demo also. So if you want to just learn something, you just click it and you will be there. After this all, they have given lots of example explaining many of those variable matrices with some example classification matrices and how you will get it. So all these are given in documentation. So if you want to learn anything, say suppose accuracy, or I don't know what is balance accuracy, so I want to know it, I clicked it, it show you the module also. So sklearn matrices balance. So how you will use in your code, you will say from sklearn matrices import balance accuracy score. So this is your method and this is your class structure, sklearn and matrices. So you can say from sklearn matrices import balanced accuracy score. So it is very easy for all anything in scikit-learn. The first, this one will tell you the how you will import in your program. So from say after that they will give you this function declaration, what is the important. So some these are like default value they have already given, so these are not compulsory, whereas this thing is compulsory. You y true and y prediction you have to pass and then you will just go through it. So it is saying the definition also compute that this one is all things have been given and then parameter explanation. So I'm just explaining this to know because no one can tell you all this in explanation. So when you are doing research or implementation, you have to learn how to read the documentation. That was one of the motive of this. So then they give you the parameter, you learn this parameter. If you know the concept of this well, then this parameter will be very easy for you. Then what is the return? They will return you a balance accuracy and type will be float. So this is one. Now example how you can use. So from, as I saying, from scikit-learn matrix import balance accuracy score. So this you can just get to your notebook or Python and just try to see how it is coming. And you can see also with accuracy and balance accuracy, what is the difference. You have papers also. I have previously also said papers. So this is the paper. It is recently published, I think 2010, and one is published in 2015. So this all come from there. So this is one matrix. So very nice organized documentation, and important thing is this source. So I said the code, whatever function you are using, you can see the source code also. So if you click on source code, this is the source code, how that have been implemented. You need little bit of advanced Python, not much, but advanced, like how we can use this thing. So this is your function, how they have defined here also all these things. Whatever you are seeing in that document, that come from here itself. That is called Python. In Python, we call doc string. That is the explanation of any function in Python. So from all these things comes from first line, if you remember, all this come from here: compute the balance, accuracy, parameter, returns, note, example. This is also in your document, all comes from here itself. So after that, they have given the code how they do this. They try to calculate and all this problem, and then they just return. So this is how they have implemented. So this is the real implementation. If you copy paste into your notebook, it will not work because there are some class call we have to do. So this will be, I think, very long part of very long matrix file. So in the top you will have lots of required library or something. If you don't have, it will not work in isolation. So if you see here, all these imports should be there. This is from scikit-learn. So if you want to make this run, or you want to make some changes, or you want to propose some new matrices, then you have to copy this GitHub repository code, hold, and then you can make change to this file in your local version, and then it will run. Then you can just test if it is working or not. So that is very nice way to contribute to the repository and use scikit-learn, and it will also give visibility to your research. So that's what I want to show. And then coming back, so I have done this performance evaluation till ROC. So better I will just try to show you the demonstration how we can apply all this with previous example we have done. So this is from yesterday. We have, if you remember yesterday, we have converted all the sentiment analysis data set into Panda data frame. We have tried to sum of this. We have converted all data set as a Panda. This one we have done, and from there we have saved. So we have made our own data set. So now, just to make it more useful, I will just try to, we have also tokenized, and we see how it is working. Then we took this word crowd, and then we stop here. So yesterday we have load the data set, we do some initial exploration, and then we stop there. So from today we are trying to now we can start with training. So this is from yesterday. We'll just try to see we can run this to load the data set. So now this is previous code. If you have tried at home, this is, I have shared that link yesterday. So now it is loading the data set. So it will take little time because it have to go through all the file and make this data frame. So till that is happening, we can come down and we will just explain this is the, from today talk, I was talking about splitting the data set. So what it is happening, once this DF will be loaded, our data frame, then we can do the splitting. So here we are doing manual split. We are not using any scikit-learn or anything. So as a problem, like I am working on this, so I can just take a decision, X train, Y train. So input value for training, input level for training, X test, input value for testing, and Y test, input for level. Now this is DF, so data frame. This is the data frame we are talking about. I think this is loaded. Yeah, this is loaded. So now I am saying LOC, and this, if you have done that Panda from first day, then it is taking the slice. So it is starting from a start and taking this much value, 24,000 from review column, and taking all the values to this one. So we are taking value, all the text file. Whereas in Y train we are taking level. So we are doing again same, but this time we are taking sentiment. So sentiment is the class level, and then value. Value means it will just take whatever we have, 0, 1 or something, or class level, that will be assigned. So now this will become our training data. Then for testing, if you see, we have just added +1. So this is again whatever we have taken for training. After that we are starting with 25,000 and we are going to whatever value is left out. So if suppose there is 30,000, then 25,000 will be used for training, because the index start with 0, so it will become 25,000 lump sum, and then left 5,000 will be for testing. So now again same, so this is your testing and this is your training. So we have done this split. So if you have run, you have, once it is loaded as a data frame, the splitting and everything will be easy. So now we have splitted. So our training and testing data is ready. Now we can move to a next part. So if you read, we are using something called, yesterday we have explained TF-ID transformer and TF-ID vectorizer. So in previous example, we are splitting the token and everything manually. Now in scikit-learn for text processing, we have by default, we have all this vectorization and transfer. So now we can use scikit-learn feature extraction, text, and then these two we can use. We are initializing vectorizer that will take all the text and convert into the vector, like all the word will become the feature. So now we are doing here, we are vectorizing. So what we are doing, we are calling this vectorizer and we are doing fit transform. We are passing xtrain, our training data, and then for test vector also we are passing vectorizer, and this time we are passing only using transform on text data. These are, we are just doing on transformation, we have to do only on training data, not on labels. So if you see there is difference, we are using fit transform and here we are using transform only. So I have put that difference. This thing is very important to understand. When you use fit, we can use separate also, fit and transform, but we have merged, we have both function. So fit transform, it will calculate the mean and variation of each features and then apply that mean and variance to our training data to rescale that value. So that is fit transform. When we have done this vectorizer, we are using same vectorizer. We don't have separate one for training or testing. So once we have done this line of code, it will be mean and variance will be preserved for later also. That test data we don't want to disclose, or we don't want to use that underlying value. So we are using same that we have used for training. So we are just using transform. In this transform, mean and variance will be already calculated in this previous step. So we don't have to use fit. If you use fit, you will get 100% kind of result, because that fit transform test data, they will use variance from the test value and then the purpose will be lost. So we have to use the variance from the training itself, and then that will preserve the variance in the test data, and we have now ready with train and test vector, and already we have label. So now if you put this shape, it is, this one is 25,000 and this is that one. So all this is the features 73,822. If you remember from yesterday, we have lots of value. We have some vocabulary of in lakhs. Now we are just having 73,000 features. So this vectorizer and transformer, they have removed unnecessary low variance feature. All this is done for us. So now our feature set is ready. So we can train this. So again, we are doing a very large processing that will take some time. So now it is done. So once everything is now done, we have load the data set, that is data collection part, and we have split it into training and testing data set. Then we have also apply feature extraction, or you say representation, and we do some pre-processing, just use the mean and variance to scale our feature. So once we have done that, now we can use classifier. So in this case, we have just used name base. If you remember the previous Bayesian base classifier, we have naive base, and in that we are using multi-nominal naive base. So this is good for test classification, and this is just for example. So we have used that. So again, training is for all method. This will be the common structure if you are using scikit-learn, where you have to call scikit-learn and then type of classifier you are going to use. So this is name base. Under name base, all the Bayesian classifier what is available in scikit-learn will be there. So you have to put the name of that classifier and then you can import. So suppose if you want to import tree classifier, decision tree, again that is under you can say by following that ever structure from sklearn dot. Now we are want to use tree. So tree import and then camel case decision tree. So this format is for all classifier. If you don't know what is the structure, then you can just look back to the documentation and you will come to know. Similarly, from sklearn, we have this is random forest. So random forest is kind of ensemble. So we have ensemble import random forest. So this is camel case always, and then you have to know this one. So now what is the problem? Why I am saying this very specifically? Because earlier this organization was not there. So because scikit-learn is also evolving over time, so they are making some changes. So if you have old code or maybe old version of scikit-learn installed into your system, maybe this organization will be differently. So you will see error like not found, this module not found. So problem is either you have a new version of scikit-learn and code is old, or vice versa. Whatever you are seeing, that code is from new version and you have installed a old version of scikit-learn. So you have to just see mismatch and just you can correct it. So now we can import the model and we can just try to train it. So this was quick. So now this is your model. So this they have taken, I have just trained is trained. So what we can do, we can break. This is single line. It is doing both work together, deciding the classifier and training. So we can just break it into two. So now I am saying CLF multi-nominal NB. So we are not passing any argument. All default will be initialized. If you want to have some specific, you can pass it here, that you will see. So now once we have initialized our classifier, we can just call classifier. CLF is the people use, but when you have multiple classifier, you can also use the name, like you can say.
Sir, the question is there in chat box, sir.
Yeah, just a minute. What is total number of record? Total number of record, I think it should be, if you edit 50,000, that that data set I think have 50,000, so they have done a 50%, or you can just a minute. So you can do that, you can find out using bf.zip. So that you have done in Panda. So 50,000. Total number of record is 50,000. And they have two column. Two column means one in one we have review and another column is for sentiment, that class. So you can, this thing you can do with basic command when you have data set. Okay, so we'll return back to. So now you have classifier initialized and you have now train vectors. You see the name from here. Earlier we have X train. When we are putting transformer, we are just putting a new name, train vector. So we have passed train vectors, and then Y train. Y train is nothing but your level, training level. So this thing is compulsory for all the supervised, where you pass the data and you pass the level. So always you pass the training data, then you pass equivalent level. If you have mismatched that, yeah, is there. This is just to demonstrate the split. We have just put 50%. You can do anything, but traditionally it is done 70 to 30. And I also explained when I was explaining cross validation, the random split is not very robust measure to divide your data set. So people use cross validation, that I will explain further how to do cross validation. This is the purpose is to demonstrate how we can use trend test a split, but there is no rule. A guideline is mostly people have 70-30%, and it is largely influenced by how many samples you have. If you have lots of samples, then you can just have as much in your training part and testing part. So there is no fixed rule. There is a suggestion of 30-70%. So mostly people use the 70% for training and 30% for it. So in this case, you can do instead of 25, you can do 70,000 for training and 30% for testing, 30,000. So there is no fixed rule. And what is the basics of taking 215 cell 2? So 250, not 250, this is 2,500, 25,000, not 2, yeah, this one. It is not 2500, it's 25,000, 25,000. So it means we are saying it is just in Panda, if you have done that, what to say, list slice, sorry, if you have done a list, so suppose you have a list, if you have a list 1, 2, slicing, you just do in Python, we do slicing. So 4, 5. So if you have something like this in a list, so you do the slicing. If you do print temp, if you start and this one, so it will take 0 and 1 element. Then if you do temp and you do 2 slice, so what it is saying, it will take this temporary list, it will start, if there is no index, it means start with 0, so it will start 0 and 1, and it will take 1, 3, and if you have given index, it will start with 2 index, and then there is no index at the last, so it will take all. So similar thing is also applicable on our data frame. So if you run this cell, you will get something like this, 1, 3 and 5, 6. Now we have 2 lists, both having 50-50%. So same thing is done here. We have just tried to take the 50% there. So that is a split. That is normal slicing. But in machine learning, we don't use that kind of manual slicing. We have very defined function. So I will show you how you can do that also. Just to make it clear, there is manual way and you can do this cross validation and other thing. Yeah, I think, is there any way? So I all questions have been answered. 30% you're taking, yeah, instead of taking 30%, you are taking 50%. Yeah, I am taking 50% just to demonstrate. So now back to our training. So already we have done this training. So it is saying our model is multimodal. Now we can do very first accuracy. So accuracy score, the first matrix I explained, that is how many correctly classify. So this is again under matrix, and then now it is a simpler syntax. Whatever classifier name you have given, CLF, you call that classifier, and then you call that predict function. So all the classifier, it is clustering or regression, everyone will have this fit function, and everyone will have this predict function. That is core of scikit-learn, fit and predict, fit and predict. So every model will have fit function and every model will have predict function. So you call your model with predict function, and this time you pass the testing data. So what is your testing data? Here you have transformed your testing data. So you call that testing data here, and then you call your predict function from your model. Now you get the predicted value. So this predicted is the class level given by this predict function for all 25,000 of your test data. Now how we do the accuracy? We call our accuracy score and we pass our levels. Y test is our testing levels. That is, we are split here, Y test. So this is our testing levels. We call the testing level and we pass our predicted value. So this is, if you remember that confusion matrix, we know the true levels and we have passed the predicted level. So for all the matrix calculation, we should pass these two values. What is the true and what is predicted? What is true and what is predicted? If we pass this thing, then we do our all the metrics, all the performance metrics we calculate. So we pass accuracy score these two value and they give us this one. So when they have in tutorial they got 79 and we got something 83. So what is the purpose? These are name based probability based classifier. So this value will change. That is not a stable. Little bit variation will be there always. So that we have to see. So now if you run this, you get this much accuracy. So this one is, that's it. We have trained and we have tested our algorithm. So we are getting this. So this is not very robust. We can do now confusion matrix. We can do all the recall and everything. So till now we have done loading our data set, text data set into a data frame, Panda data frame. Then we perform a manual splitting of 50-50% training to testing. And then we use scikit-learn vectorizer and feature extractor to convert our test into the feature TFID. And then we use multinomial NB base to classify. And we got this accuracy using accuracy score. So this is one pipeline. We collect the data, clean the data, whatever we perform, we do the feature extraction, we train and test our model. And then after this, if you want, you can save this model also, that I will demonstrate. So you have this model, CLF is model, still it is in memory. If you don't want to go this whole process again and again, then you have to save your model, and next time you just have to load your model. So that is very easy. And then if you have this save model as a file, then you can put into your web server, your mobile app, or whatever way you want to do that. So that also I will demonstrate how to save a model. So I think any question is there? So I think we are running little short on time. So if you have any question, you can ask now, and then I can move to next topic. So I think we have another half an hour. Am I right?
Yes, sir.
We have left half an hour for this session, right?
Yes, sir.
Okay. So if you have any question, then I can answer. Otherwise, I can move. I have lots of demo to demonstrate. If no question, then I can move. So second example, I have used from again this 2R data science, and this time, so in previous example, I have used a data set that we have downloaded on our local machine, and then we have done all the processing. So now scikit-learn or all the machine learning module or deep learning module, they come with some pre-data set or pre-installed data set that is available. If data sets are freely available, there is no copyright issue or anything. Then these model have, this framework have also included those TWI dataset. Sometimes we call it TWI dataset because already many people have worked on that dataset, and that is very stable, but still people use for testing their method and algorithm. So that is TWI dataset. So scikit-learn also come with lots of TWI dataset. There is a list. If you go to scikit-learn website, they have published a list what are the dataset they have. So in this case, we use this cancer dataset. So loading dataset is very simple. From scikit-learn dataset import, and whatever dataset name you want, you can go. So if you want to see the dataset, model processing, feature extraction, dataset, SK dataset. So if you see, this is the dataset sklearn have. Sorry, these are the dataset. All this loader, clear dataset, all this dataset they have. So like that, we have news data, news group dataset. We have many. This is the dataset we are using. So you can see what it will return, what are the features. So it will say everything. So this is about the default dataset. So a structure is same. From sklearn dataset import load breast cancer dataset. It will return you X and Y. So if you come here, it will return data, bunch of data, target, feature name. This all thing will be returned as a this one. So you can also directly you can download it from this source UCIML, and they have also included. So simple, this one how you can download or you can use. So we have used this. So this is easier than previous method because scikit-learn have taken care of all the loading and everything that we have written that function. So Scikit have taken all those care as this function, and then we can just get this, we can just get our function. So once we have get this one, so now how we will get our X and Y. So X is our training data, or X is data and Y is the level. So now this is just a dictionary. So we can take this variable and we are saying give me the data, and we are saying give me the target. So most of the data set is organized like this. So this is BR is a dictionary, and then we pass the value data, it will return us data, and it will pass target. So it will pass data. So now we got our XY like previously. So then one important way is like just to demonstrate, we can do a scaling also. Like in if you have different kind of value, they have different range of value. Then in classifier like decision tree, they take if larger is the value, then they have more number and other things. So to make those algorithm working fine, then we have to do the scaling. So for a scaling and all this pre-processing, we have lots of function in our sklearn. You can just go through the document and explore. I have used one standard scalar. They just rescale the feature value to their unit variance. They take every column, every feature, and they calculate the variance, and based upon that, they rescale all the value. So for that pre-processing module, sklearn pre-processing. So this is that module. Under that, lots of these things are there. So we are using a standard scalar. So a scalar is equal to, we can just everything like model, we have to just call our standard scalar. If you want to pass some argument, you can just look into the comment, and if you want to optimize, if you have some idea about what value you want to optimize, then if you take argument, you can just pass the value. So we just call our scalar. Like previous example, we have called fit transform, and this time this training data we want to scale. So we have passed that x, and now we say it x scale. So again, it will calculate the variance for every column and then apply to all the column value also. So it is learning what to do, and then it apply also. So that is merge of two function, fit and transform. So that is the scalar. So we have just scale it. So now if you want, I can just run it one by one. So a scaling is done. So now from previous many one have asked me that the split. So now scikit-learn also come with this feature. It is in model selection. So there is a difference. Earlier it was under cross validation or some other organization structure. Now it is under model selection. So you might get error if you have all previous code or something. So from scikit-learn, now if you see, we are calling train test split. Sorry. So we call this function, and it return us 4 things. The same 4 that we have done in previous example, xtrain, y xtest. This name you can give anything as per your naming convention, but this is the suggestion and convention people use, xtrain, xtest, and it return 4 this tuple. So the same thing, we just call our function, and then we pass our training data and training level, and we pass, this is the value. This is the split we want to say. If 0.3 means 30% for test. So test size we are passing 0.33 means 30%. So now this will divide. If you are using with previous data set, we can just call the same function, this function, and we can say 50%. So that 50-50 will 80-20. Then we can say 20% for test 0.2, and then it will split. And then this last one is just to seed the value, random state 42. If you use the same code, the people will have same result. This is not mandatory. You can remove this also. This is just to make your output and my output same, because we are just initializing the random state with some seed value. So that, so once we have done this, once we do this, we get our previous all these things. So now I am just trying to show more models. So we are trying to classify this time never, k-never, SDD classifier, and then logistic regression. All are in different structure. Scalar neighbors. So all will, this instant-based learner will be there. Then we have linear model that you saw in that. We have SGD, and then in linear model itself, we have logistic regression. So this is the organization that scikit-learn have organized in their model. So you can just call all this model, and now all this code are repetitive KNN model. So now we have more than one model. So instead of CLF, people use like this. You can use directly KNN also. There is no necessary to write KNN model. Just you can write KNN, but there will be some confusion. So just to make it clear, people use this kind of naming convention. It is again up to you what name you want to give. So KNN model again initialized, and this time we are saying we want to consider 3 never for making any decision. So k never is equal to 3. So this value we are passing. If you are not passing, scikit-learn will have some default value, maybe 2 or something. So that is initializing our classifier. Once you have that initialization, then you can similarly you can just pass to the fit function. All fit function like same, xtrain, ytrain, xtrain, ytrain. Likewise, all this classifier you can initialize and train. So if you train this, all this classifier have been trained, and now like to predict. So this is just prediction, KNN model.predict, SGD model.predict, and we are passing again the test data. So very similar to previous one, but now we want to this is also accuracy score. Already we have done that accuracy score. So similar thing now, that is not new. So confusion matrix. So accuracy score we have done. So I have moved to the confusion matrix. So we have our Y test that we know the true level and we have predicted. So now we can do one by one for all classifiers. So confusion matrix is in your matrix package. You can just call your confusion matrix. It's take two argument, Y test, the true level and predicted level, and then it will give you. So if you remember from previous, true positive, false positive, true negative, and true positive, true negative this one, and false negative this one. So this is the result. So as I said, this diagonal 59 and 105, we want to have more and more value. So 3 and 4, it means it is good classifying. So if you see Canon performance 95, so this loss of 5% is coming from this and this one. So that is confusion matrix. You can calculate, you can learn this background, how we can do it. And then I also try to put how you can plot. So this plotting like graphics is always better. So you can plot also. This code is taken from Scikit-learn itself. So Scikit-learn matrix, we have plot confusion matrix also. Very nice. Here we have confusion matrix and here we have plot confusion matrix. So you can do plotting also. With that, now take three argument. Is take the model, the trend model that you have trained, and then take the same thing, X test and Y test. So you pass these two things. X test is your training data and Y test is your training level. So it's take the model and this thing, and then it's plot the confusion matrix. So this is little different whatever we are passing. Here we are passing the prediction. Here we are passing the training and testing data, like how we are doing the training. So it's take these two and then it plot a nice confusion matrix similar to previous one, same results. So it will like having same. So now you can understand, you can do more labeling with plotting. I think yesterday you have plotting session, or maybe tomorrow you will have some MATLAB plotting session. You can learn more how to do labeling and all the title and other thing. Likewise, now everything is similar what I have explained. So I will move further. So all this I have done there for other thing also. So this is again similar thing with plot and everything. Now we will do precision and recall. So I try to just calculate more precision and everything. So this is, I will just run it to make it more useful. Yeah. So this is repetitive. So I am not going in that because we are running short on time. I want to complete this one. So precision, as I explained in the presentation, you can just calculate. I am calculating for the last one. You can just take it, the value, true positive, true negative, you can just add and divide. Normally also you can do, but there are sometimes you make mistakes. So there are method for that. So scikit-learn, this time we have something called classification report. So this is taking all this confusion matrix inside themselves, and they calculate precision, recall, precision, and F1 score, and give you a very nice chart for all the classification. So again, this is under matrices, and the same target I am taking just to label. So targets, the same target's name, like whatever target they have used, and then now you can do classification report. Instead of taking confusion matrix or accuracy score, you can just call classification request. You pass the testing level, predicted level, and you can pass the name. This is just to label the class name, malignant and benign. So these two, you can just pass it. If you don't give this, this value will come and you have to understand what is the meaning. So if you pass the target, so suppose target is like, simply if target is like apple and orange, so then we can just pass this target here. So that is just to label this value. So you can have this one, and then for all classifier you can do, and then you can get very nice, classification report for every class. So this precision and recall or true positive, positive, we can calculate for all. So you get this very nice chart to report in your work or whatever to understand. So this is your classification report. Now moving further, so ROC curve. So ROC curve is like we plot FPR ratio and TPR ratio. So scikit-learn, like this is like bare minimum that we have to do this all performance metrics. So scikit-learn comes with all this pre-built method. Now our task is to understand and interpret this result. What is the result? Why it is coming? If it is low, why it is low? Why it is high? How anything we are making any mistake in algorithm configuration or calling the value. So all this depend upon the data scientist or machine learning engineer. They have to decide. But scikit-learn come with all this pre-built function and method. So for plotting our ROC curve, we have this plot ROC curve function under matrices, and it's very simple. Plot ROC curve, we pass the KNN model. This all are from the example in scikit-learn documentation itself. So we pass our text data and we pass our test level. These two things and the model, what model we want to use. If you remember KNN model or SGD model or whatever model we have used. So we pass these three value, this function calculate everything and then give you a very nice plot with AUC calculated internally. We don't have to calculate AUC separately. AUC is calculated. So that is your AUC value. So this is for one. You can do for all three. We have done three. So there are some difference that we can see here. And then this is done. So now we have 10 minutes. So as I said, now this code I will explain and then we can take question after this. So now I think this code reading will be very easy for you. So all this 4 line, we are just calling 5 classifier. We are not doing anything else. We are just calling 5 classifier. Any question is there? Okay, no question. So all these 5 classifier we are calling. Nothing new. Now you understand all are in different ensemble, tree, neighbor, naive, base, linear. So different classifier we are calling. We want to know the matrix ROC curve and ROC AUC score. So that is again this function call. Now this is something different we are doing first time. So what we are doing here, we are not calling. In previous example, I have initialized all the model one by one. We have tested confusion matrix one by one. That's very lengthy code and sometimes it create confusion also. So a neat way is we can use or we can just initialize all this classifier as a list. So I say classifiers, that is nothing but a Python list, and we initialize all as a object element of that list, all the classifier. If you have to pass any argument, you can pass. So all this 5 classifier is now become a initialize into a classifier object. So this is object list. So in Python, list can have anything, object, class, integer, a string, all list can have anything. So this is list of object, class object. So that is just initialization all in once. Then we have created one data frame. So we are creating a empty data frame where we are putting classifier one column, FPR another column, TPR another column, and AUC another column. So this is just a this one table. So if you want to print it here, then I can just print, or I can just take this out and print this result table, and I can insert a new cell. So if you so till now I will just run it and show you what is happening. So classifier is not defined. So I have run the wrong set. So now I have done. So this is the empty data frame, classifier, FPR, TPR, AUC as a column. So that is that first part. And now here we are doing just looping. We are not training one model at a time. Sorry, all model at a time. We are just looping through our classifier list, initializing that model with train and test data, taking the prediction, calculating FPR using ROC curve, and AUC using this function. Then we are inserting that value to our table classifier FPR. So we are passing also what happened after this loop. All these 5, 6 classifier, they will be trained and tested, their FPR, TPR, and ROC will be calculated and added to this table that we have created, result table. So once we run this table, and if we print this table, so after doing this print, it will have something called classifier, all the classifier name, FPR result, TPR result, and AUC. So this is one data frame table, Panda data frame that hold all our result. Now we are ready for, so what is the purpose of this? We want to plot all this ROC in one diagram. To do that, we have just created this Panda data frame. Once we have done that, now it will be very easy to plot. So plotting we are using matplotlib, this function. So by now you'd have been familiar with calling the import. So now we are saying a fixed array, and then if you see, we are just calling our result table based upon the index. So index is nothing but our classifier name. So you are taking all the classifier name one by one, taking our result value FPR, TPR, and then AUC value. So with this, we are now plotting. So we are saying orange color and everything. So this false positive will come on the here, true positive is coming this one, and ROC curve is this your heading. All these are just printing, nothing. Here we are not doing any machine learning. This is just matplot plain printing of this diagram, because all FPR, TPR value we have in our table. So after running this thing, we will get you this nice ROC curve where we have plotted all this. This is called baseline, this horizontal line, it is showing baseline. Further this curve, better the classifier, and then we have also printed all the AUC here also. If you see this curve here, if you see, we have given the tick. Yesterday someone was asking me that image X and Y, that value that I was not knowing, that is, but here I know this is starting with 0, 0 to 1.1, and this is the meaning our TPR value, this FPR will be only go to 0 to 1, not cross the 1, because 1 is the perfect classifying and 0 is the burst. So it should be between 0 to 1, but we have used 1.1 to just show you this gap. Otherwise, if you put 1 only here, if you just put 1, then you cannot understand that curve will be touching this. Yeah, it will be like this. Now it is showing till there, and this. So to make it clear, just we have used that extra point. So that is the, so this is your ROC curve for 4-5 classifier. This is the way how we report our result in some publication or some presentation. We can have individual classifier ROC also, or we can have separately also. If you want, you can also calculate table also, because we have ROCs. If you see AUC is in a table, you can report this result also. If you want, you can just take some and you can report from recall another thing also. So this is done, and we can save also. So this diagram, if you want to report in your paper, you can save this and it will be as a PNG file. So you can automate all your experiment from reading the data to generating and saving the file. So if you have new idea, you just change the top and then everything will be saved. So that's how you can create ROC curve. There are some other than scikit-learn NLTK, there are many other natural language processing toolkit. So this is just a list. Today I will be sending this note back to everyone. So you will get this. So with this, I think we are toward the end of this session. Am I right? 5 more minutes we have. If you have any question, I can take, and then I have some left out that I will present into next session. Yeah, if any questions is there, I can take it. Yeah, Habiba, I think we are.
Sir, we don't have any questions. It was cleared.
Yeah, so I think we are about to end of this session, right? Am I right? Because we have time
Yes.
difference, so sometimes I get confused.
Yes, sir. Actually, it is a break. We can have a break and or else, do you want to continue, sir?
No, we want break for, because
okay,
it has been.
Sir. Resume by 11:30, sir.
Yeah, so we will come back after 30 minutes, right?
Yes, sir. After 30 minutes. By 11:30, we'll start the next session.
Okay. Okay, thank you.
Okay, thank you.
Thank you. Yeah.